Boom! Alright folks, how are you going? So welcome to yet another in our series of maths videos. In this video, we're going to look at one of the often neglected ways of finding the area of a triangle where the CXC syllabus is concerned. And I say neglected because it's right there in the syllabus, you know. But strangely enough, and I may stand to be corrected on this, in all the years of past papers that I have been through, both as a student back in the 90s and as a teacher from 2014 coming down the road, I have not seen a question that explicitly called for the use of this method. In other words, I haven't seen a question where this was the only possible way to find the area of a triangle. Alright? There may have been questions where it may have been one of the options, but I have yet to see a question where it is the only way. Now, what is the formula talking about? This thing about how to find the area of a triangle. In the formula sheet of the exam, you would see the following formula for the area of a triangle. Right, and I'm writing it directly off the formula sheet here. They say area of triangle ABC is equal to, what's the formula now? The square root of S into S minus A into S minus B into S minus C, where S is equal to A plus B plus C over 2. Alright? This is referred to as Heron's formula. Alright? It is named after a Greco-Egyptian mathematician, Hero of Alexandria, who lived between the years 10 AD to 70 AD. Yes, I just went on Google and checked that out. Alright? It is named after a guy called Hero of Alexandria. So he would have been back in the days. You know now, we have so many mathematicians coming down through the years from different parts of the globe. So this is Heron's formula. Alright? And this video is designed to prepare students for the possibility that you may get a triangle where Heron's formula is the only choice, the only option in terms of finding the area of the triangle. And you know how we stop in this part of the world. Simply because it is not familiar. In other words, you do past papers from 1955 and you never see a question on Heron's formula. So you go and you do the exam in 2021 and boom, you get a question on Heron's formula. And you come out of the exam crying and bawling and whining. Alright? Forgetting that the formula right there in the formula sheet. Believe it or not, a lot of people don't even use the formula sheet. Alright? Now, some of the formulae on the formula sheet you will remember by sheer dint of repetition. And there are other formulae that you might be too familiar with. But I want to use this opportunity right now to encourage students and parents. Talk to your children. All of these are the little things that you have to do as part of preparation for the maths exam. Familiarize yourself with the formula sheet. Know which formulae are on the sheet and which formulae are not on the sheet. So for example, if you want to find the length of a straight line, you wouldn't find that on the formula sheet. Alright? If you want to find the gradient of a straight line, you wouldn't find that on the formula sheet. If you forget what sine theta is and what cosine theta is, yes, that's on the formula sheet. If you forget what the area of a circle is, that's on the formula sheet too, etc., etc., etc. So familiarize yourself with the formula sheet. That way, you know which formulae that you don't have the burden of having to remember. So if circles is one of your weak topics, and you just get tired with this pi thing and this pi thing, then here what? The area of a circle is on the formula sheet. Let me see. everything for area. The circumference of a circle, the area of a circle, the volume of a sphere, the volume of a regular solid, a prism, right? All them things. Most of the stuff to do with circle, area of a circle, area of a sector, area of a trapezium, etc., etc., etc. All right. So familiarize yourself with the formula sheet. Right. All of this is part of your strategizing. All of this is part of your planning the thing going forward. So you know, all right, I weak in circles, but at least I don't have to remember what the area of a circle is. Pi, pi r squared, da 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 da. Boom, you go there on the formula sheet and you find it. So we digressed a little bit just to make a point, right? And that is why I keep telling people all the time, when you watch my videos, make sure and watch the whole thing, because it always have something in there that you will miss if you find that 15 minutes is too much time to watch Hume video. So I go skim through it and see what I could pick up. No, chances are you'll miss some golden nuggets of information inside there. So make it time and watch the whole thing now. Alright? Right, so back to our good friend here. So what I will do is demonstrate using a triangle that we're familiar with, the fact that this formula actually works. And then I will just come with a random triangle and use it. So that way I will demonstrate at 2 levels of difficulty the use of Heron's formula to find the area of a triangle. Alright? Now, before we actually do the question, you notice in this formula there is no reference at all to any of the angles in a triangle. Alright? All you have are the lengths of the sides. You have the regular formula, a half base by height. That is used if the triangle is a right angle triangle, or if you have enough information to determine a perpendicular height for the triangle. If you could have a perpendicular height, or the triangle is right angle, a half base by 2, boom. Then there's also the formula where we say a half AB sine C. A half by the length of one side by the length of the other side by the sine of the angle between those 2 sides. So if you have an angle on 2 sides, in other words, if you have 2 sides and the angle between them, a half AB sine C is the formula that you could use. If, however, you have a triangle and the only information you have is the lengths of the 3 sides, and they tell you, find the area of that triangle, then you have no choice but to use Heron's formula, in the absence of other information, of course. Now, the S referred to in this formula is A plus B plus C, all over 2. This is called the semi-perimeter. As you know, for any triangle, right, where you have A, B, and C, the perimeter of the triangle is A plus B plus C. So A plus B plus C divided by 2 is the semi-perimeter, however you choose to pronounce it. Semi, of course, being a reference to the fact that you're dividing by 2. So in other words, you find the perimeter and you divide by 2. That is the semi-perimeter. Boom. That is the S. And then you just use S in the formula here. So let us demonstrate the use of Heron's formula by first finding the area of a triangle that we're familiar with. Then we use Heron's formula to find the same area. That way we verify that the formula actually works. And then we use it on another triangle. So the simplest triangle that we could use is, guess what? Our good friend, the right angle triangle. Alright? And if you would have looked at any of my videos on the website, it was on Facebook as well too. But if you would have looked at the videos on trigonometry, Pythagoras theorem and trigonometry, at some point in there, you would have seen reference to the 3, 4, 5 triangle. I'm not going to explain that here. Go in the videos on the website and check it out. And one variant of the 3, 5, 4 triangle is 6, 8, and 10. So in other words, we have one length, let me call that 6. We have the other length. Now that's looking like a longer length there. So let me leave that as 8. Let me leave that as 6. And then this here is the hypotenuse. That is 10 as a right angle triangle. So that is a triangle whose area we could find by using the formula a half base by height. a half base by height, right? I'm going to say a half base by height over 2. Base by height over 2, a half base by height. Alright? So the base is 8 and the height is 6. So the area of this triangle is 8 by 6 over 2. 8 by 6 is still 48. 48 over 2 is equal to 24. So if we have this to do in an exam, we run through that in a matter of seconds and we get that out. We're familiar with this. We know this since whenever. So let us now do the same thing. Find the area of the same triangle. But this time we're using Heron's formula. Alright? So with Heron's formula, we know that S is what we refer to as the semi-perimeter. So what's the perimeter of the circle? Perimeter is 8 plus 6 is 14. 14 plus 10 is 24. Now, isn't that a delicious coincidence? The perimeter in meters, or let me say meters for now. The perimeter in meters is the same thing as the area in meters squared. So this now is an excellent example. You see how these things are? I didn't even plan that. I just choose random figures. This is an opportune moment to talk about the whole question of units. If we're talking about length, the unit of perimeter is length because it is the length of this side plus the length of this side plus the length of this side. The length of the perimeter, let me say P, perimeter is equal to, let me spell it, the people wouldn't know. The perimeter is equal to 24, let me go with meters, right? Meters is unit of length in the SI system. 24 meters, the area of this, the area is 24 meters squared, or 24 square meters. That is two totally different things. Alright? I'm not going to spend too much time explaining the difference between these two now. I will probably do that in another video. So this is another video that we just generated there. Alright? So be careful, be mindful of the units always when you're doing these questions with length, area, and volume. Of course, if we're talking volume, we're talking cubic meters, meters cubed. Alright, and of course, if we're talking about centimeters cubed, we know that 1000 centimeters cubed, or 1000 cc, is equal to 1 liter. Different discussion, another place and another time for that. So this is just a delicious coincidence, but do not mistake this 24 for this 24. These are two totally different 24s. This 24 is a unit of length. This 24 is a unit of area. Sorry, a measure. This 24 is a measure of length in the appropriate unit. We're using meters here for now. This 24 is a measure of area, and the unit we're using here. If length we measure in here is in meters, then the unit would be meters squared for area. Alright, so if the perimeter is 24, then it means then that your S, which is the semi-perimeter, is perimeter over 2, which is 24 over 2. So your S, which is the semi-perimeter, is 24 over 2, which is our good friend 12. So this S is the S. So in other words, sorry, the S is equal to 12. This S is the S that we're going to now use in the Heron's formula. Alright, so we're rubbing off all this now, and we're going into the formula of Heron. Alright, so we know that by Heron's formula, the area is equal to the square root of S into S minus A into S minus B. Leave some space here into S minus C. Alright, let me put back the 10 here. Alright, that's the hypotenuse. We know that S is 12. So the area then will be equal to the square root of 12 into, and again, I'm going to take the opportunity here to write out everything. Yes, we know 12. How are we labeling this thing, boy? Now we go anti-clockwise now. So A is equal to 8, B is equal to 6, and C is equal to 10. Alright, this is the letter that we're going to use. We know 12 minus 8 is 4, and yes, for the purposes of an exam, we could just put 4 in here one time. But for my purposes of teaching, I will make the extra effort and write out everything, just to demonstrate how you write the thing out properly. Alright, so this is 12 by 12 into 12 minus 8, S minus A, into 12, let me make a proper tuner, man. 12 minus B, 12 minus 6, into 12 minus C, 12 minus 10. That's the Heron's formula right there for this triangle. Alright, so this will be square root again, 12, 12 minus 8 is still 4, 12 minus 6 is 6, and 12 minus 10 is 2. Alright, the square root of, let me multiply now, 12 by 4 is 48. Let me take two numbers by a time just to be safe. 48, 6 by 2 is 12. Alright, 40 by 12 is how much? 40 by 10 is 480. 40 by 2 is 96. 40 plus 96 is how much? 576. That's 100 minus 4. Right. 480, 40 by 12 is the square root of 576. And, ladies and gentlemen, boys and girls, damas y caballeros, the square root of 576 is our good friend 24. So you see what happening here. Alright? We get the same area of 24 that we got here. Now of course, if you're in an exam and you get a right angle triangle, you're not going to use Heron's formula. Alright? When you have options, you utilize the options. When you don't have options, then yes, you have our formula here to fall back on, the Heron's formula. So we demonstrate using the regular triangle that our Heron's formula actually works. So we're gonna come up with a random triangle now, which you know the internet now. I went on the internet and I found a little program, a little application where I could generate any kind of triangle. So I went and generate a scalene triangle. Of course, if you're generating a random scalene, it is much more difficult to get a random scalene with perfect integers. But that is fine, because we want to consider the topic at varying levels of difficulty. So here now we're going to use a triangle where we have only the lengths and we don't have these nice neat integers as we just had here. We're going to use lengths where we have decimals to deal with. Alright, so we're going to rub off the board now. Alright, we now just demonstrate that Heron's formula actually works. And we're going to use a random triangle now. So, what's the triangle? The base is 6.8. Triangle looking like this. 6.8. The other side is 6.1. That's something like this. And then we have a 7.6. I don't make it look kind of longish now. Right? So this is 7.6. Let me say cm. This is, what's the other figure there? 6.8 centimeters. And this is 6.1 centimeters. So we land in an exam and we have this triangle. Now of course in section 2 in your maths this would be question 9 in the 2018 syllabus. Geometry and trigonometry. That is where you'll probably have to end up dealing with Heron's formula. It is unlikely that you'll have to use Heron's formula in section 1. Section 2, however, is a horse of a different color. So you're in section 2, number 9, and you see this. Now, this might be it might be a follow-on from a previous part of the question, or this might be the first part to set up the remaining part of the question. Either way, you reach here, and you find yourself being asked to find the area of this triangle. Now, of course, the units of the area would be centimeters squared because the units of length are centimeters. All right, so we go, excuse, I'm a calculator. Right, I definitely need the calculator for this one. All right, whew, yeah, boy. So in this one, we go to Heron's formula since we don't have any other choice. All right, we don't have any of the angles. And let us assume, for the sake of explanation, that there is no other information in the question that will allow us to calculate these angles. Sometimes you get a situation like this, but there's something else in the question that you could use to calculate one of these three angles. And if you have one angle and you have three sides, you don't have any problem. But if all you have is three sides, no angles, then to Heron's formula we go. So our S, which is, and I'm writing it out here, just to make sure that everybody remember, the S is perimeter over 2, so S would be what? 7.6 plus 6.1 plus 6.8 all over 2, and that would be, well, let me do the thing now. 7.6 plus 6.1 plus 6.8 equal, and then I divide that by 2, and that is 41 over 4, 10.25. All right, so S is 10.25. Now, invariably, the nature of this thing is that the S will always be greater than any of these three lengths. So you don't ever have to worry about S being less than one of these three. All right, so your S is 10.25. So therefore, your area, using Heron's formula, which I write now the whole formula here just for the sake of repetition, but in an exam, you wouldn't have to necessarily do this, right? You wouldn't necessarily have to do this in an exam, but I do it here just for repetition, so you can listen to me talk and see it. You see it once, you see it twice, you see it 3 times, yeah, right? Repetition. That is equal to the square root of, let me see now, 10.25 by, I'm putting this in brackets here, 10.25 into 10.25 minus 6.8 into 10.25 minus 6.1 into 10.25 minus 7.6. So this is where the calculations start to get a little unwieldy, unseemly, and yes, folks, that is what section 2 in the maths is about. Add maths even more so. Right? You know the formula, you know what to do, but yeah boy, pressure. There's all kind of thing here. Alright? So you're gonna rub off everything on top here and go back and continue. So we have the formula here, so we can rub off everything else on top here now. Step 1, step 2, bam, 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 bam. Right. So we go it. So you rub off and you start. So from here we go back to the top and we get that that is the square root of. Yeah, we go straight in the line a little later. So this will be 10.25 in brackets by 10.25 minus 6.8 is how much? 10.25 minus 6.8 equal 5.45. Okay, 10.25 multiplied by 5.45 multiplied by 10.25 minus 6.1 is what? 6.15. When you get something that you could minus in your head, you do that, right? This one you need a calculator there now. 10.25 minus 7.6. I could take time and do it, but we don't necessarily want to do that. The exam is not the place for that, right? By 2.65, all right? And that's the area there, all right? 6 point, yeah, that's double checking there. All right, so then you multiply all of these things and you get that the area is equal to, now we take them 2 at a time just to be safe, all right? 10.25 multiplied by 5.45 is equal to 55.8625. Alright, brackets 55.8625 and 6.15 by 2.65, 6.15 by 6.15 by 2.65. I sure I said 6.25 just now. Did I or did I not? Anyway, 6.15 by 2.65 is equal to 16.2975. 16.2975. And then we multiply those two and we get what? 16.2975 multiplied by 55.8625 is equal to 910 points. Let me put it. 910 points. 4190938, and the square root of all of that is, let us see, drum roll. The square root of all of that is equal to 30.1731518.7. Of course, you're not going to leave the answer like this. In section 2, and generally, they will usually tell you how much decimal places or how many significant figures. But, and again, this here is one of the little things that they could miss if you try to skim through my videos. The 2018 syllabus specifies that if there is no clear instruction as to the degree of rounding off for your final answer, that you are to adopt 3 significant figures as the default position. So in other words, if they don't tell you 2 decimal places or 2 significant figures or round it off to the nearest whole number, then you are to express your answer to 3 significant figures. 30.1731518.7 to 3 significant figures is 30.2. Right? How I get that? Hold on. I'm going to write the thing properly now, man. 30.2. Right? Make a proper 3 there. Now, how did I get from here to here? You know I'm not going to go through that in this video. Right? 3 significant figures. However, I have a whole video in my website where we talk about significant figures, and we didn't just talk about significant figures. We talk explicitly about the difference between significant figures and decimal places. That is one of the early topics. That is in fact a topic that will show up very often in question 1 in the CSEC Maths paper 2. The thing, however, is that it is something that you will use throughout the paper, most especially if they don't specify explicitly what level of rounding off to put in your final answer. Alright, so you are welcome, more than welcome, to check out my video on my website where we talk about significant figures versus decimal places. Another thing I want you to notice is that in the question, notice that I didn't round off here and I didn't round off here. Let me come on this side. I want you to see my face when I'm talking about this. I didn't round off here. I didn't round off here. I didn't even round off here. And I didn't round off here. Right? And this is something that I always have to deal with my students. And I'm taking the opportunity now to mention it on the video here. Because one of the mistakes, and I'm using the word deliberately, one of the mistakes that people make in doing these questions is that you're doing the calculations and you get this and this. And out of sheer laziness, you decide to put 55.9. No, 55.9 here and 16.3 here is a different. Let me actually demonstrate the difference between the answers you'll get when you round off. Alright? So let me say, for the sake of argument, that we say here, right now, I put it in red here, what some people would put. The square root of 55.9 by 16.3, right? Some people will do that because they're fed up, right? They're fed up, they're tired, right? Good. So 55.9 by 16.3 is how much? By 16.3 is equal to 911.17. You see the difference there already? 911.17. What's the big difference between this and that? Right? That is a difference of almost 1. And then you find the square root of that. And you get, well, in this case, you actually get the same answer. You get 30.18. Let me go to the 0.18. And that to three significant figures is 30.2. Right? So you get away here. Right? But it doesn't change what I was actually saying. Which is, don't. So in other words, and again, this is an excellent opportunity for me to talk to students, because sometimes you do something in one question and you get away with it. And you make the mistake of thinking that you'll get away with all the other questions. So you do this one and you get the same 30.2 that you get here. Alright? And because of that, you tell yourself, anytime I have a question where I have all of this to do, I will shorten it up here and get whatever I get. That, my friends, is a mistake. Do not assume that it will always work out like this. There are questions in similar circumstances where you get 30.2 here and you cut up the number here and you might get 31 or 32 down here, or 29, depending on how you cut it. Alright, so for example, if you decide that you're too lazy to write all of this, to write even this, and you go with 56 here and 16 here, then it's a different level. Alright, so for example, again, let me do it just to demonstrate, right? If I go with, how was squeezing this in, boy? If I go with 56 here and 16 here, right? You tell yourself you fed up at them decimals, you only want to work with whole numbers now. Alright? So 56 by 16 is equal to 896. So you see what happened there already, right? 56 by 16 is 896. So this time we're going down. 56 by, yeah, because we dropped from 16.2 to 16 here. Even though, right. And then the square root of 896 is what? 29.93, which to three significant figures is 30.0. No, 29.9. Sorry, my mistake. 29.9. So, for the really lazy people who find why I need to write all in decimal places, you didn't even use 55.9. You use 56. And you use 16. You see what happened here. If you move from here to here, with the one decimal place, you end up at the same point. But do not assume that that will happen every time. That is not the case. So as a general rule, the general rule is simply this. You use all the decimals in the belly of the question, in the working, taking care to write the thing properly. And it is only at the very end, when you get to this point here, that you now come in and say, let me round off. Alright? Whether it's to the nearest whole number, or to two decimal places, or to three significant figures, those are the usual suspects. They will either usually ask you for the nearest whole number, to two decimal places, or for three significant figures. but they could ask you for something else too. So for example, they might ask you for two significant figures, which in this case will work out to be in the same thing as the nearest whole number. Two significant figures here will give you 30. Alright? Three significant figures is 30.2. If for some reason they decide to harass all and ask for four significant figures, then the answer will be 30.17, which is the same thing as asking for two decimal places, which in this case will be the same 30.17. Again, go to my video on the website, you see all of that, we discussed in a nice way. Nice? So, the proper thing to do is to avoid the lazy approach. Don't fall into the trap of shortening these numbers up here. You do it wrong enough at the very end. That way, you preserve the accuracy of your figures coming down. Right? And when you round off, you know, well, you're sure that the answer is 30.2. Here, your level of certainty is not so much because you would have rounded off earlier on, you're really not sure of how much error you introduced by simply doing that. And there's a whole range of calculations that you could do to find out that. But as a general rule, don't shorten your working. You write it out and you round off at the very end. That way you're sure that is 30.2 to three significant figures. You're more sure than you would be over here. And if you get even lazier and go with the whole number as well, right, that's not even worthy of consideration. Alright, so I hope, trust and believe that this video has been of use, that you would have been numerically edified, and as always, the encouragement is to come back, because we have more in our series of videos that we're putting up online in terms of social media, Facebook and whatnot. Alright? We also have the website where you'll find this same video and a truckload of other videos, a lot of which I wouldn't put up on social media. So we put up some on social media and then you go inside and you get even more. The challenge for you now is to find the time to master the self-discipline to make use of the videos, because I can almost promise you, I can almost guarantee you that if you make the proper use of these videos, in terms of you watch the videos with no distractions, no distractions, right? You do the questions, you collaborate with somebody else in terms of the answers. It might be me you're collaborating with, who knows? And you use that in tandem with any other thing that you're doing, maybe your teacher in school or whatever it is, and you apply the appropriate work ethic. You're on your way. You're on your way, first of all, to understanding the thing, and secondly, to passing the people exam. Alright, so take care. Bring somebody, come back again, because we have plenty more coming your way. Boom!